This conference will now be recorded.
Fine. So once again, for those who don't know me, my name is Adam. And what we are trying to do, so we are trying to learn DevOps. And in that, the first best practice of DevOps, which is what we call it as continuous development. And as part of continuous development, in the previous session, we understood how an organization should be adapting to agile process. And in an agile, how you're going to do a release planning. And following the release planning, we also saw that what is that we have to do in a day-to-day activity, whether if we follow a agile scrum or a Kanban. So that is what I was trying to talk. So now with this details, when you have to actually get your work done, because now we have a requirement and we have decided what is our release plan, and we have broken down our release plan into epics and stories and tasks, so that now you actually have a task in hand to do. So what is the next thing that you're going to do? So we are going to start writing code. So when I say start writing code, let me again repeat what I said yesterday. A code is not just about program, because for a product to release, the program that you write is one kind of code, but other than that, there will be a lot of supporting work that you have to do, for which again we generally call it as coding. So that is where writing a shell script or a Python script or a PowerShell script is also called as coding. Or you might have to write some kind of configuration file, or technically we call it as developing a configuration file. Okay, so that's where most of the time people will be calling. Even if you're writing 100 lines shell script or a Python script, you are developing. So that is where there will be a lot of things that we have to develop for our release to happen. In that, if you are a programmer or an actual developer, you will be writing some kind of a Java program or a .NET or a Node.js, whatever it is. But if not, there will be a lot of other people wherein for doing automation, you also have to develop some script or some tools or some configuration files or even a document. So this is where what we need to understand now is, for any given project, how is that all of us are going to do the development together? Where are we going to store all these files? How are you going to maintain? So that is where in the continuous development, now all the guys have to work together. So that is where there is another best practice which the industry follows, is what we call it as version controlling system. Okay, so that's when, what exactly is a version controlling system? So now let's forget about the release for a minute. Please go on mute. Okay, so now what I'm trying to talk about is, so you have decided a release, and for that some changes has to be done for your software, which could be a program, or it could be a script, or it could be some configuration file. Okay, now regardless of who is doing, we will still look it from a bigger picture. For a product, now there are many files that have to write and store. So that way, in a day in and a day out, the actual programmers or the developers or the people who will be writing many files, because what is a program? If you just understand in a layman term, program is nothing but a file inside which you are going to write some syntax, so that when you execute it, you will be getting some output. So that way, the question now comes is, for developing a software, there are many files that you have to write. So for a product, it is not just that you will be having one file. Now take your WhatsApp as an example. You are installing WhatsApp. So for installing, there might be some one executable or a binary file which you download and you install. It's not just WhatsApp, any kind of application. So there is one file that you install, but internally, have you noted, when it gets installed to your C drive on Windows or in Linux to some folder or on your mobile, it's basically collection of many files. So that way, that many files has to be actually written by some people, and that is what will be converted later into a actual executable, or what we call it as object files. Now I'm not going into build detail, but just give an idea. So this way, for us to develop a software, there might be many files in which we have to write the code. Okay, now again, I'm not worrying about whether it's a Java code or a C code or a .NET code or a Ruby, whatever it is. Now, can I achieve everything in one file? No. So this is where many developers will be working, many people will be using the same file. So what will happen? Now, let's correlate this to one simple example for understanding better, because if there are people who are not from the background of development or from IT, now take this example. All of us are going to work together and create one storybook. Let's assume that this is the plan. So what is the product we are going to sell? One storybook. Now, when you storybook, what will it contain? Many pages. But a book can be divided into chapters. So that way, when you sell, you are going to put all the chapters together. So let's now say I'm the manager for that. Okay, and I'm dealing with the customer. So now I'm giving the responsibility to all of us. So in my book, let's now say that I have 4 chapters. Okay, now for that chapter, I'm finding out group of people and I'm telling, okay, hey, first group, you work on the first chapter, second group, second chapter. So that way I'm dividing it and giving the work. So what is that each group is going to do? They are going to take some pages and start writing some story. Now, if you understand, to achieve a story, how many pages each group will be taking, it's up to them, because there might be one chapter which is a small chapter, like introduction to something. However, the middle chapters might be very long because you have to explain something. So this is where the same number of pages cannot happen. So depending on what context they are writing or what subject they are writing, the chapters might be differing, and because of that, the number of pages that goes inside will also differ. Okay, so now if I have a plan to release my book in a matter of 30 days, then how should I work? So every day I should go to everyone and ask, hey, how many of you have completed? Give me that so that I can do a review and tell you whether it is good or is there a spelling mistake, right? Now that is not going to happen, because if I have 300 people working, I cannot sit with everyone and find out. And the second problem is, if one group has completed, how will I know whether this is the first chapter that I should start reading, or should I wait until the first chapter people or the group completes? So this is how, for me to create a group, I need to have some order. Then let's assume I'm telling, okay, hey, today I'm going to review, give me all your changes. Now let's assume all the 4 group are coming together and each one of them is handling some 100 pages. Now out of this 100 pages, how will I know first, which page I should keep it first, which page I should keep it last, right? So if I mix it, then it is going to be a problem. So I don't know which page is related to which chapter. So this is how, even for a simple story that you want to create, there's going to be a lot of problem. Because in this, if I now find out one page has a problem, then I have to go and ask him that, hey, can you please modify, it is not good. And what if that guy says, hey, I wrote this because it is depending on my first chapter. In the first chapter, something he has written, that is why I have mentioned it. So what you have to do now, you have to modify the first chapter and come back. Now to coordinate all these things, it's going to take a lot of time. This is what exactly happens in a software development. So now replace your storybook with a product and replace the pages with files in which you are going to write program, and replace the people who are working with developers or QA engineers. So what will happen now? The same problem like I was explaining yesterday. So if I can divide my product, okay, into, let's assume, major 4 functionalities, and I'm assuming, let's say that a group of people are working, I will not know how many files that each developer will be creating, or I cannot tell whether the same file has been modified by multiple people or multiple developers. And if I want to take a file, which file should I take? Should I take the file from the first developer or second developer? And in that also, if there is a dependency, how will one developer will know that the other developer has completed his work? So that is where when we actually start writing code and storing all the code as a file, then you need to have a proper way of organizing it. So that is where in an organization, even not now, from a long time, we used to follow this concept called version controlling system. So what does it tell? It tells that, okay, now if you're a developer or a person who are writing some text file, don't store it wherever you want, store it in a common location. So this way, what will happen? We will request everyone to refer to a common location and store and maintain there, so that if you want to do work, take a copy from the central location or the common location, modify in your place, and then share it back to the central place. So this way, what will happen? Now, if I want to refer to some latest code, I don't have to go to each and every one. I can just go to the common location or the central location and take whatever is available. Same way, if one developer depends on another developer, without going to him, if he can just go to the common location, whatever is available, he can refer. So this is one way we can have a better communication. Okay. And the next problem that it will be solving is, when you actually take a code as a file, it might be containing multiple lines. Now in that, what happens sometime, one developer will modify the file and put it back into the central location. Another developer will take it, and on top of it, he will write something else. So this is when whoever is trying to use the product or test the product as a QA engineer, if they take that file, which is the latest file, it might not work. So now, how do I know why it is not working and which code is causing the problem? So that is where, if I take the file, it will always show me the latest content. But how do I know who put it? How did it come? So that is where, when we are trying to put the content into a common location or a centralized location, we follow a process wherein we will follow a process in which we will say, whatever changes you are doing, we are going to track. So tracking means I will make entry. Like if someone stores a file or even multiple files back into the common location, we will make a note, okay, this person at this time modified all these things, and in these files, these are the lines which got modified. So this way, every change that you are going to do to a file or a group of files and you are storing back into a common location, we will be able to track. So this is how the process called version controlling system will help us to have a track on who and all are modifying the files, what got modified, when it was modified, why it was modified, and if I want to take the latest change, I can take the latest change or the file from my central or the common location. Okay, so such a kind of process is what we want everyone to follow, which is what simply we call it as version controlling system. Once again, what is it? If you are developing something and you want to store a file, all you have to make sure is go to a common location, take the files from there, modify on your local machine and put it back. And every time you're putting it back, the system, whatever that you are trying to put it there, will start tracking, which will clearly tell who modified, when was it modified, and why was it modified. So this is how, if there is a problem, I can clearly tell, okay, the problem is because of line 10. So who introduced the line 10 in it? So if I go back and take a history of who and all has modified, to get it. Okay. So this, we are going to follow a system which will help us to track what and all changes are going in. Okay. Plus, is that the only thing what you're going to do? No. Now this is a common location or a central location. So at any point of time, if anyone wants to refer to a product or refer to the latest files of a product officially, then they should be referring to the common location. Okay. And as well as, it will also give us a control. So what do you mean by control? Now I told you that, okay, there are like 100 developers working. Now everyone will try to write code and they will be storing the code back into the common location. But for certain reasons, I don't want everyone to do that. So that is where, if you have such a requirement where you want to have a control on who should modify, who should not modify, then you can do that also in the common location. So all these things is doable. So that process wherein if you are going to have a common location in which you can have a control on who should modify and who should not modify, and for every change that you are trying to store it back, you can have a control and keep tracking of what and all changes happened. So such a kind of process is what we call it as version controlling system. Okay, so by implementing it, whether you are a developer or you are a QA engineer or any kind of automation engineer or support engineer, anytime going forward, if you have to think about storing some text related file, again, make a note of this point. I'm talking about text related file. I'm not talking about binary files, because there is a separate concept and there are separate tools for that. So we are focusing on, for a software release, what and all files that will get changed, which is a text related file. If you want to store it and maintain it, then you're going to follow this process called version controlling system. So developers are the people who would be using it heavily. However, all of us will be using it at some point of time, because we might also write some kind of code which is related to a script or some automation or a configuration or a document. So no matter what kind of text file you're trying to write, all of us have to use it. So this is what I will again tell little later. Okay, so this is where in DevOps we understood what is continuous development. For that, exactly, if we are trying to modify a file, what we have to do is we have to follow this process. Okay, so this is where, how are you going to follow this? So for this, there is a tool available. So like this, for every best practice, there is a tool available. So this is where, for implementing the version controlling system, earlier in the market, there were different tools available. So right from the beginning, if you see, there were tools like CVS or RCS, and then things like ClearCase came into the picture, and then Perforce, TFS, Subversion. So there are plenty of tools that started coming into the market. Now, out of that, Git is one of the popular tool which was used in DevOps, because now if you understand all the earlier tools that I was telling, that is Subversion, ClearCase, TFS, or Perforce, all of them were mainly used by developers. But now, as we are moving towards the DevOps culture, we are focusing on more and more automation. So any one of us can write some kind of code or develop a script or a document. So that is where all of us have to store some files somewhere. So that is when what we need is a system which is very simple, or a process which is very simple. I don't want something huge, because see, for a developer, storing thousands of files in your repository, if you have a big tool, it is okay. But let's assume I'm not a developer. I am part of a QA guy who's writing some test suite or test automation script, or I am a support person or an admin who's writing some small script. So for me to write and store, if I use a huge tool, then it will be too much of overhead or maintenance. So that is where in DevOps, we are not going to just think of doing automation, but we are also going to think on how effectively can you do the maintenance of the work. Okay, so it's not about using it. It's also about maintaining it effectively, so that it should be easy and simple for using and maintenance. So that's where Git as a tool became popular. So that is where, knowingly or unknowingly, wherever you go outside, everyone will say, oh, if it is DevOps, you should know Git. That is reason, because for doing the actual parallel development, working with different people and different products, it will be quite easy. So that's where now we need to know how Git will be helpful for us to do all this activity. Okay. Now, before I get into Git, let me first explain you what are the terminologies that we will be using in the version controlling system. Okay. Now, before I move further, is there any question for those who don't understood what is version controlling system? Is it clear, or any questions on what is version controlling system and why is that now it is important for everyone in the culture of DevOps?
Adam, can you hear me?
Yeah, go
Adam,
ahead.
can you hear me? Yeah, Adam, I would like to. This is not about version control, but this is about Git. Um, Probably it might be a hasty doubt, but I've been having this doubt for a quite long time. In Git, if you take, we have a couple of terminologies are being used. Well, a few people are saying Git, few people are saying GitHub, few people are saying GitLab, and
Okay,
I'm not sure like
Ganesh,
what is the difference. Yeah.
Ganesh, I got your question. Yeah, again, I'll repeat this. Whatever that you're going to ask, we'll be covering because I haven't even gone into what is Git and different
Okay.
terminology. Okay,
As I
so
said, yeah.
if you understand, I'm going it
Mhm.
from a proper level where I made you understand what is agile, what is continuous development, and in that, what is version controlling. So first, I want you to clear. And now, as we go into Git, that's my first thing today we are going to learn. But anyway, for others, what is that we are going to learn today? We will understand what is version controlling system, and in that we will understand what is Git, what is the architecture of Git, what are the different terminologies of Git, how it is used, how is it set up, what is that central repository, GitLab, GitHub, all those things, and then we will start getting into the actual commands. Okay, so that way my question was, if everyone understands what is version controlling system, then I'll move ahead. But anyway, I'll explain what you are asking, Ganesh. It's part of the subject.
Adam, one quick question, Adam.
Yeah.
So, irrespective of what technologies we are coming from, maybe storage, maybe networking, maybe, or servers, maybe, or just the monitoring teams, maybe. So, the significance of version controlling remains the same across fields. I just want to know how significant could it be for me personally, coming from networks background.
Yeah, it's going to be the same. Like I said, if in your day-to-day activity you have to store some file which can be reused, or we have to share it with someone again and again, whether it could be a script or it could be a configuration file or even a document, I am sure, pretty sure everyone will be doing all those things. So where are you going to store?
Okay.
Don't store in any of the common location in your machine, but store it into a common location which is called as VCS. And the advantage of here is it is going to be one place of proof, and you are going to have a complete record of what is going in, who is modifying, when was it modified, and there are pretty much you can also give a control on who should see, who should not see.
So pretty much across various different technologies, technology practices, it is going to be an important task. Yeah.
Yes. So anything you are going to develop, think of using it to store those files. What you are developing, again, I'm repeating, it's fine if it takes little minute, but understand development doesn't mean you're developing a program. It could be a configuration file, it could be a script, or it could be even a document. You are developing something for a release. And if it's a text related file, start using this concept and store the file. Okay.
Yeah, I remembered yesterday's your line. It's almost always there will be some file, either a configuration file or some file we have to deal with. So if I remember that yesterday's line of yours, then it all makes sense here. There will always be
Yeah.
some configuration file. It doesn't mean development only. Some scripts will be there, some files will be there. Yes.
Adam,
Sure.
Adam Premier, just
Go ahead.
I have a quick question. Yeah. Will there be any internal database reside in the VCS or any system? I mean, any
Yes,
control
I'll
version
talk
control
about
system.
the architecture. I'll talk about that. Okay. So as we move on, like I said, the architecture, I'll explain what is that you want to know.
Thank you. Thank you.
Adam, I have a question.
Yeah.
I have one question. In version control, if we submit multiple users at a time in version control, so how can you identify first user submitted this document and second user that submitted configuration file? So is there any clue? How can we identify that? That is my
Yes.
question.
Yes, I'll be answering that also. Okay.
Yeah. Thank you.
I'll answer
Adam,
that.
one quick question. Why we are calling this a distributed version control system? Why can't we call this a version control system, since we are just taking the code, making our changes, promoting it? So why we are calling it a distributed version control system?
Okay. You will also get the answer for that as we move on to the slides. Okay.
Okay, fine.
So that's
Thank
what
you.
I said. Hold back.
Adam, I have the one suggestion. Can you give me the 1 minute? please finish in this VCS term section few steps, then give the people to ask the question, because as you're telling that everything is coming in a coming slides. So I think we have to wait for some time. Let slide will finish, then we can ask the question. So we can save the time and also we can understand the things. If hope everybody will be agree with me.
Yes, agree. Yes, correct.
Yeah. So my point again for that is, if I mentioned clearly, I said don't jump into anything else, because all those things what you're asking is there. How to take it, that's what I'm trying to do it in a proper way. But just my question was to make sure first, do you understand what is VCS? So with that understanding, so now you take any tool. Again, I'm not talking about Git or any other tool. So most of the tools that you are already using, it works in a concept called server and a client architecture. So what do you mean by a server? So server is nothing but a place where you are going to store everything. So now what happens is, when you go to an organization, you will be having a server in which you are going to store the file. Okay. Now, to compare it better, think as a bank. So in a bank, there is some common location and all our savings are going into it. Correct? Now in that, if you understand, each of us, let's say that all of us have a bank account like HDFC. Okay, I don't have any preference, just an example. But let's assume there are 100 people with having 100 accounts. All the money is getting stored in the bank. But is it that all of us are storing together? No. So that is where there is some kind of boundary which is defined, and whatever that we store will be within it. That is what we call it as an account, right? Because using the account, we will be able to track, okay, this is what you have stored. The same way, in VCS, what are you going to store? All the files related to your product. Now, there might be multiple products that you're going to store in the server, which is nothing but like a folder. Now, how are you going to store? So rather than storing into together, we will be dividing it into layer, or consider it like a folder. So server is a machine in which I will create separate folders, just for assumption, and I'm going to store everything separately. So in this example, I might have 3 products, and I'm going to store all the files related to my product A into this, and product B into this, and product C into this. So it doesn't matter how many developers are working, all of them are going to store the files in the respective folders. And that way, in a bank, you call it as an account, but in VCS, this folder is what we call it as a repository. Okay. So now if you understand, repository is nothing but a location in which all the files are going to actually get stored. Okay. So this way, in VCS or in a server of a VCS, you can have many repositories. So it all depends on your company's need and how big is the server you can store. But remember, if I say a repository, all the files related to a product is what you're going to store here. Okay. Now, so when you're going to start your work, your interest, let's assume, is only to start modifying an existing file, or you are going to create a new file for a product. So that is where you will be working on a different machine. Okay. So now you can use your laptop, or you can have a separate machine given to you in which you are going to do your development work. So again, when I say development work, you are trying to modify the file and try to change it. So that way, that machine in which you are going to work also needs a software which is called as the client side. Okay. So what is the responsibility? Is going to communicate to the server and help you to see the content of a particular repository. See, it's like a ATM. Now bank will be having all the accounts, but depending on your need, you will go to a ATM nearby and use that to connect to the server and see your account, right? The same way, when you are working in VCS, you will be having a client, but inside the client, which is nothing but your machine, what you are going to do is you are going to create a folder. Now, why do you need this folder? This is the folder inside which you are going to see the content of a particular repository. Okay. Again, remember, it's just like a ATM. So in an ATM screen, if I want to see the account details at a time, I will be able to see one account details, right? Even though I can have multiple account at a time, I can see only one. The same way, When you have files in all this repository, if I want to work from my machine, I will install client. Now I cannot take a copy of all of them because this might have 100 files, this might have 1000 files, and this might have even 10,000 files. Where will I put it? How will I segregate? Correct? So that is where we are going to create a separate folder, wherein this folder will try to show you only the content of a particular repository that you choose. Like how in my ATM I say, hey, connect to my particular account, right? Using your account number. The same way, what you are going to do now is, you are going to communicate to the server and tell you are interested to work on one repository and you want to see the files of that. So that way, when you request the server, the client will connect to the server, and in the server specific repository, it will copy the content and it will put into this folder. So that process of getting the files from the server from a particular repository into a folder in your machine through client is what we call it as checkout. So now if I want to first see my files, then I have to do this concept called checkout. Now how to do what command, that is what is going to change from tool to tool, but it's just more of a generic concept I'm telling. So
Adam, it should be check-in, right?
No, please wait, I'll explain what is it. Okay, so first what we are trying to do is we are trying to see the file, because if you have to start developing, first you want to see the file. If there is a file already available, you need to first see the file, right? So that is where, is the file going to be available? Because let's assume you are joining a company and they have given you a laptop. Now in that laptop, if you have to start, first you should take the copy of that from the repository. So that is where checkout means you are going to take a copy of the file from the server, wherein whatever is available, you will get a copy. Now that is called as checkout. So when you say checkout, it is giving you a copy of the file, and then after you get the file, you will start modifying whatever file that you want. And once you have modified all the files, you have to store it back into the common location. So that way, after you have modified, if you want to store it back into the common location, then that is what we call it as check-in. Okay, so the simple difference, checkout means you're taking a copy of the files from a repository to your machine into a folder, and once you modify, you are going to put it back into the repository. So that is what is called as check-in. So this way, for every user, you will be having a separate folder in which you are modifying and seeing. That folder is called as workspace, as the name says. This is what you are using it to do the work. So it is nothing but a folder in your machine or in your laptop. Like this, every user will have their own workspace in their machine, or the same user can have multiple workspaces depending on different repositories. So you are going to modify, and when you are going to check in, it will go back to the same repository. So let's assume you checked out from repository A, you modified, and when you are storing it back, the check-in will not put it in B. It is going to go back into the A, just like your ATM. You go to an ATM and you connect to an account and you do some transaction, it is going to store back into the same account. Okay. Now, what happens is, like when I said a bank, if you try to do some transaction, it will go to your specific account, and every transaction that you do, whether you are removing money or adding money, it will be tracked as a transaction ID, and that will be unique. So that is how, if tomorrow you are trying to get the details of your account, all you will say is take a statement, and that statement will show you what and all has been transferred, how much has been put in, and how much has been removed. Okay, so that is what we call it as a transaction. In the same way, in version controlling system, every check-in that a person does has typically few information. So what are the information the check-in carries is, first, which repository you are modifying, and in that, what are the files which is getting modified, and in that file, what exactly or what line have you modified. That information will also be there. Plus, who is the user who is modifying. That information will also be available, including the timestamp. So that way, just like your bank transaction ID, remember this as an example, which will be very easy to correlate. In version controlling system, every time a user checks in, it will take the details on who is modifying, what are the files being modified, and what is the content which is being modified and when it was modified. So just like a bank transaction ID for an account, for every check-in a person does, it will be having the details. So like this, if you understand, for every check-in, what you are creating a transaction, right? That transaction is what we call it as version. Okay, and that is why the name of the tool is given as version controlling system. Earlier, these were called as source code management tools, but now to make it simplified, because it is not only the source code, almost all the text files can be stored, they changed it into VCS. So the name came from this itself. So like how you call transaction IDs in a bank, for every check-in, whatever the transaction you are doing, that is being tracked as a version. And what is this? It's actually a metadata, okay, wherein it's going to store who modified, what modified, and when was it modified. So this way, in every repository, for every check-in that a person does, it is going to keep a track of what is being modified. Same way, now, if you want to work, you will have to create a workspace based on each repository. So this is where, now let's assume I completed my work in project A. Now I have been assigned to work on another project. Then if I have to work on project B, let's assume, then again I have to do a checkout, take the copy of the files from repository B into my new folder, which is workspace, at the second, which is a different workspace, and I will modify and I will do a check-in. So this way, each of us will be having a client and we are going to modify and do a check-in. So this is what is your regular process that you're going to do. Okay. So by this, it should be clear for you now what is server, what is repository, what is a workspace, and what do you mean by checkout and check-in. Okay.
Hi, this is Suresh here.
Yes.
We are discussing the subversion, right? The topic.
Okay. I'm not talking about subversion. This is generic. Whether you take subversion, whether you take ClearCase, Perforce, TFS, any tool that you have worked, this is the normal process which is called as VCS. Okay. Every tool. The naming will be little different, but this is the process.
Adam, you mentioned that there is a metadata, right? Is that metadata is applicable for the particular user or applicable for entire repository?
It's for entire repository. Whatever that you're going to store will be stored in the repository.
It will contain multiple user information, right? Say Adam, Prem, or whatever people, all those information will contain in the metadata, right?
For every user check-in happens, there will be a separate version that is going to get created. So that way, metadata is specific to a repository, but inside the repository, each version is specific to a user. Same user can do multiple check-ins, but if different users are doing different check-in, so each check-in will be referred to a version, which will be a metadata of what user, what modified, and when what was modified.
Okay, and one more question. Can you do multiple checkout in at a time?
Okay, the concept of checkout is seeing the file. Now, if you have already checked out, you already have the files inside the folder, so you don't have to do a checkout again. But if you want to create another workspace or folder, then you need to create another folder and then you are going to do a checkout. So if you compare it with what the question you are asking, I have go to an ATM, I have already connected by giving my password to one account. Should I again log in? No, until the end of the transaction, you are going to use. But for various reasons, if I have to connect, then I have to use a different ATM and then try to use. The same way, for one workspace, you're going to do one checkout and you can do as many check-ins as you want.
Okay, perfect.
So Adam, does checkout also, whenever you make any checkout, so whether the information is stored in the repository or it is just a checkout, only at the time of check-in, the repository, metadata is maintained in the repository?
Yeah, I'll talk about it. There's a little change in what you are asking because from tool to tool it will vary. I'll talk about the problems of that.
Okay, fine. Thank you.
So now with this understanding, now if you understand, yeah, there are many tools available, but why is that industry started using Git? And especially when we say DevOps, now what the hell is DevOps? If you literally understand, it's all about automating and making sure that you can deliver faster and make sure that the maintenance work is also good. So that is where, when compared to all the other tools, for every one of us to use, Git was used mainly for a couple of reasons. The first reason is it is speed, which means if you have already worked on many tools and if you are going to work on Git, it will be quite faster. How it will be faster? We will see that. And second, there is something called as non-linear development, wherein if you are working on other tool, there will be certain limitations, whereas in Git, you do not have that limitation. Now, what is that? Again, we are going to see that. And again, when you take other tools are not fully distributed, but Git is distributed. So that is where, again, what is this distributed? We are going to know. But other than that, from a simple user level, Git is lightweight and process is going to be very easy, so that we can easily install and maintain. So that is where it's going to be quite popular, whether your repository is going to have 10,000 files or you are just modifying with 2 files, the process is going to be the same and it's not going to take much of the time. So that is where people started using Git, and in DevOps we prefer because it is going to help us to do our work faster and it is simple and maintenance is also less. So with that, now let us understand the problems. So if you look at this diagram, I have mentioned 2 diagrams. Now first, what I want you to look at is my diagram which is on the left side. Okay, so the model that I was trying to explain you so far, right, the VCS terminologies, that is called a okay to be
Adam,
only
you're not audible, Adam.
yeah, there was a disturbance.
It's breaking
Network.
in between.
Yeah,
Your voice is
Adam.
breaking.
Yeah, there was a breakup. Yeah.
Yeah. So I'll repeat it anyway. So
Yes,
in
please.
a product, there is going to be one repository. Okay. So where are you going to store? So you are going to store it in a server. So that way, if you are following an old tool, there will be one server. Okay. And in that server, for every product, you are going to have. Okay. So that way, remember, one product, or for every product, there is going to be one repository in common. Now, all the tools that you guys were talking about, Subversion, ClearCase, TFS, right? They work in this model. So this is where, for your company, you will set up one server, and for every product, you are going to have your repository stored. And then, as a user, if you are going to work, in each of your machine, you will install the client, and in the client, you will do checkout, modify, and check-in. So that is what the process you will be doing. Now, what are the problems that you're going to face in this? So let's assume that your organization is, kind of geographically distributed, and because of that, the repository that we are going to maintain is on a different location. So now, if you are going to work in a different location, when you say checkout, what do you mean by checkout? It is like typically copying the files from one machine to another machine. Okay, now think of it like this. What if I tell you are working on a project which has like 10,000 files, and each file will contain more than 100 lines? Now typically it is like downloading a movie. Okay, so now depending on the region, if you are trying to do a checkout and you are trying to copy the files from your repository to your machine, if that itself is going to take minimum of 15 minutes or 20 minutes, then assume in a company I have 100 developers working, and each developer spending 15 minutes just to do a checkout is a huge amount of time that we are wasting. Okay, That is one problem. And second problem is the same. When you modify, once again, when you do a checkout, it is going through the network. Now this is where, what if there is a network issue or a network latency? Then what will happen? If you are a user and you want to store it back into the central repository, then you have to wait until the network is fine and then it will go. So that is where the concept of checkout and check-in is going to be delayed. Now, how much? It's just a exaggeration. I'm just trying to tell you, but even if 1 minute is being wasted, assume how much of time that altogether I am going to spend. So that is where there will be little slowness. Then what are the other problems you are going to have? Now, if there is a network issue and there is no communication between my machine or the client and my master, I will not be able to do a check-in, because let's assume that I'm a fast developer. I keep doing changes like this. Then if I want to store, then I need to store it into the central repository. If it doesn't happen, then there's a slowness. And not just that. So let's say I'm trying to do some POC. What is POC? Proof of concept. Now, I don't want this to be available on the central repository. Then how can I store only in my machine? Because there is no backup. But if I try to store anything into the central repository, now it is common to everyone, which means anyone can take the code, which could be wrong. So that is where, as a user or a developer, you are supposed to store everything into the common location, which is not at all good for a developer, because I want to test and only the code which is fine I want to store. But if I have to do all those things in the common location, then every code that I'm modifying is also getting stored. So that is where, for a developer, he cannot do any trial runs, or he cannot do just some random coding unnecessarily. Now that is when we have another problem. Then what happens if, assume I am working with another developer and both of us are together working to achieve a solution to a problem. For that, we have to modify some files. Now, I have modified a file which is available in my machine, in my workspace. How will I share it to other person? So this is where, in the regular way, either I have to do SCP, but it is not just like one file, right? I have to give my entire workspace, because there will be a lot of dependencies internally. So again, if I have to share to this person, I cannot share directly. Then the only process is I have to put it back into central repository, for which I have to do check-in, and this guy has to do a checkout from there. So the process is getting delayed. But once again, what if I'm not interested to share it with everyone? Then once again, everything has to go through central repository. So this is the problem that we have, which is going to actually slow down the development process. Okay, because now we are focusing on continuous development. Now many changes has to be done. So how is that you are going to make the user's life easy? So that's where Git comes in. So now what I want to think is, go back to the previous diagram. Okay, so that is my centralized tool. Now in this diagram, what if I say you do not have a server at all? Okay, so remember, if I am saying that there is no server, then what is left out in this picture? Only client and workspace. So this way, now in Git, there is no concept of server. Okay, so in Git, everything is a workspace, which is nothing but a folder. That is the first thing you need to know. Okay, why should I have only folders? Then the next question is, okay, now if I have to work, what is that I have to do? First, I have to check out the code from the repository so that it will come inside my workspace. That is why we need something called as workspace. But now, if I say there is no server, then where is the repository will be? So that is where in Git, everything is a workspace. And in every workspace, you are going to have a copy of the repository. Okay, I'll repeat it. In Git, everything is a workspace, and every workspace will have a repository copy. Okay, now how is it going to solve the problem? Okay, Guys, if you have an audio problem, I would request you to disconnect and connect again because it depends on your network. Okay. Now, what I'm trying to tell is in Git, everything is a workspace and every workspace will internally have a repository. So how is it going to solve my problem? So now go back to the actual problem that I said. If you are a user, you are working in Git, you will get a workspace. How do you get? We will talk about it. But let's assume now I have given you a workspace. Now in that workspace, you will also have a repository inside it. Okay. So if you have to now start writing your code or modifying the code, the first thing you are going to do is checkout, right? So this way, if I give you a workspace, which will also have a repository, and if you want to do a checkout, you will do the checkout from your repository. So that way, the file will get checked out from this repository in your workspace, and it will be visible within the same workspace. And how much of time do you think for that? It will not be taking much time because it is available in your SOEM folder. So checkout will be instant. Okay. Then you modify the code, and next what you are going to do? You are going to do check-in. Now, when you are going to do check-in, where are you going to store the check-in? So this is where, once again, when you say check-in, it will go to the repository. So for you, which is the repository available? On the same workspace, there is one repository available. So when you do a check-in, it will immediately go to the same folder. So that way, how much of time it will take? It's very fast. So that is when checkout and check-in will be faster for you. Okay, so it solves one of the problem. Next,
Adam,
what is the
can
other?
you please repeat again?
In Git, everything is a workspace, and in every workspace, you will be getting a copy of the repository. So this is where, if you are going to work, the checkout and check-in will be done in that workspace and within that whatever repository you have. So that way, whatever you are modifying and checking in will be stored inside that repository. So this way, you don't have to worry about the time because it's going to be super fast, which is first problem solving. Okay. Then, if you understand, for every user, if you create a workspace, every one of them will have a copy of the repository which is owned by them. So that way, now, unlike earlier, if I want to do some changes, I will do the check-in, and where will it be available? It will be available in my repository. The same way, if any other user modifies the change, it will also be available in his repository. It is like carrying our own ATMs with us. Okay. So this way, the benefit now again is.
Adam, I have one question here actually. Uh, it's like if we have one larger project and hundred of developers are working there, so do every developer has a whole code in his repository?
Yeah, I'm coming to that. Okay, so we'll talk about that. It's a good question. So now, yeah, from where you are going to get, we didn't go into that. First, we are still understanding the repository. By that way, yes, you are going to get the complete repository available in your workspace. So that way, now, when you do a checkout and check-in, all the changes is available only inside your workspace. So this way, if there is another person and if he modifies, it is available only in his repository. Now, what is the problem that or the advantage you are getting? Now, anything I modify, I'm not sharing with anyone else. I'm still keeping it in my repository. Whereas what happens here? If you try to store it to keep a backup, then it is going back to the central repository where everyone is seeing. But now, if you are trying to do check-in, where it is storing, it is available in your machine. So that is where it doesn't matter with network. So every user will have a workspace, and every workspace will have a copy of a repository, and whatever changes that you are doing will be stored inside it. So this is how it will be quite easy for a developer to just start doing his work. So I don't have to worry about others. I can start doing my changes, and I can store the changes as long as I want into my repository, which is actually getting tracked. because suddenly I want to know, hey, 2 days back I did some change. I want to know what exactly did I do. So that is where I can go back to my repository and ask for a statement, which is nothing but list of versions, and I can find out, oh, this is what I did. So it looks like this is the modification I wanted to know. Okay, fine. So this way, it will be very useful for the developer to find out this. Okay. Now this way, it solves another problem. But going back to the actual workflow, as a developer or as a user, you are free to modify anything that you want inside your repository. But what is the point of modifying? At some point, you have to share it to a common location, like a book that I was telling, right? You can start writing pages together, but when I want to create a book, I have to combine. That way, one time where if I want to share my changes to everyone, then where are you going to put? So that is where, whether I want to share the changes or I want to refer to what others have done, we should have one more common location. So that is where in Git what we will do, like how you had a copy of a workspace, because everything is a workspace, I told, right? You will take another copy and make that copy as a centralized repository or a centralized workspace. So what is the difference now? As a user, you will be having a copy of the workspace, and that will be available in your machine, and that will have a repository, and you own that workspace, you own that repository. However, we will have one more common copy of the workspace, which will also have repository, and this is for common to everyone. And that way, whatever as an organization we are going to refer to this common repository, okay, which is generally called it as central repository or remote repository. So in fact, now if you understand, when we have to create the first process or the first workspace that we should create is the central workspace or the remote repository. Because as a user, if you want to start working, how are you going to get the workspace? So that is where you are going to make a copy of the central repository for the first time. Then whatever is available in the central workspace, you will also get it as a copy, and you will also get a repository, and you modify all the changes that you want. And finally, when you decide that your changes are ready to be submitted back to the common location, or it is going to be into the actual product, then you are going to share it back to the central repository. So that is how every user will have the freedom of modifying the changes in their local workspace. Then they are going to store it back into the common location. Okay, that is the whole process. Okay, so this is where, what is the flexibility now it is giving? So as a user, you can find out that I will get my own copy of the repository. I can modify as long as I want. And then when I am going to share it with others, all I'm going to do is share it with the central workspace or repository. And not just this. This is where, if you understand, everything is nothing but a workspace. The central workspace has one repository which is common to everyone, whereas these are individual workspaces which is owned by a specific user. So now I can choose to whom I have to share the change, because if I decide that my change is very good change and I'm going to put it into the centralized location, then I'm going to share it to the central repository or remote repository. The same thing now, if I want to share it to the developer, which is another problem I told you, right? Like if I'm working on a POC, I don't want to share it here. If I want to share it to a person, I can choose my repository and I can share it. So this is why it is called as distributed. So you can share changes, what you have done between two repositories. It could be between two local repositories of a user, or it could be between your local repository and a central repository or a remote repository. So that is why Git is called as distributed. Whereas in other tool, there is only one repository. So anything you do will always go here. So by working in this way, Git has a lot of benefit to the user because first, every workspace has its own repository. So you have the complete freedom of what you are modifying. And at any point of time, you can decide to store it, and you want to share it. You can share it with an individual, or you can share it to everyone by putting into the common location. Okay. So this is what Git is going to work. And this is what is going to help us to do the continuous development or parallel development in a better way. Okay. So that's why Git solves all the problem that I was talking about earlier. So remember, in Git, everything is a workspace and every workspace has a repository. But as a process, what we will do? First, we will create the central repository, and from there, as a user you want to work, you are going to create a copy of the workspace, and then you are going to start doing your work. Okay, so this is the whole concept.
Adam, here the
yes.
Go ahead, please.
Adam, one question. Yeah, one question. See, if you in a centralized model, if you lose computer A, if you I consider the computer A and B is crashed, can we restore the code whatever we are doing in the client side? Can we restore it in the centralized model? As well as distribution model also, can that be possible? If I lose server computer, can we use the data which is in the server computer one, computer A and B? Can we restore it to the server computer A? Can we make it happen again?
The whole concept of having a common repository is not just for sharing, but it's also for storing. So that is where the best practice what we follow is, whether you are using centralized model or distributed model, every time or very frequently, once you modify, don't just keep only the changes in your repository, keep sharing it to the central repository. So that way, if your machine crashes, you are not able to get back, I can go to another machine. In that machine, if I try to make a copy of this workspace, I'm going to get everything again so that I can start doing my work. So the best practice is start taking workspace, modify the changes, and keep changes.
No, my question is, if I lose server computer, I mean the primary server, can we restore the data using the computer A and B?
Yes, that is where you need to know that how are you going to take a backup, because now I still didn't go into the part how you are going to set it up, what tool you are going to use. I told Git, but in Git also there are different parts. Okay, so that is more about the maintenance and exactly what you said. As a user, now there are two things that you need to know in Git. Okay, so one is working on the local repository, and the second part is managing your central repository. So that is where you are going to have two roles. Okay, I'll talk about that also as we move forward. But again, like I said, there are a lot of things. It's not just Git in the sense 4 commands. You need to know what is going to do, how you're going to do the work. Okay, now if you have understood the difference between centralized model and distributed model, now let me just walk you through the architecture so that before you run or maintain the commands, it's quite necessary for you. So now if you understand, it's the same question someone was trying to ask. Okay, so if you say that my local workspace is nothing but a copy of my central repository, will I have everything in my local repository? Yes, but the difference is, let's go back to your bank. When you say that you have an account, regardless of how rich you are, does it mean that your bank account has all of the physical money? No, it's more of the numbers, right? The same way, if you say repository, the reason why I earlier told the word called metadata, because it is not storing your files. It is basically going to store some metadata on what exactly you have modified. So that way, if I have a file, just for one example, I might modify the file 1,000 times. So Git is not going to make 1,000 copies of the file and store into repository. But instead of that, what Git does is, Git uses a concept called snapshot, which is nothing but difference between what I had earlier and what I have done now. So it is going to just take only that information and like a screenshot of your machine, how you capture everything. So that way, it is going to take a difference of that and it is going to store it. So like your bank account, what you will be having in your account is full of transaction IDs, right? In the same way, in Git repository, what you are going to have is fully information about versions. That is where Git is quite efficient. Because now think, if your repository has 10,000 files and there are 100 developers modifying this file in the past 3 to 4 months, how many changes you are going to have? So you're not going to keep that many copies of the file. So that is where Git is going to store only the version information. So that is where when you try to create your own workspace, it will give you a copy of the repository, but from that we can choose what to see and how to work. And that is what, as we move forward, we will be seeing. So remember, Git uses internally something called a snapshot, and that is what it is going to store all the metadata. Okay, so there is nothing called as completely a database, but yes, it uses the concept of snapshot and keeps a version information of what and all has been modified. Okay, so now if you dig in little deeper, in the bank, if you do a transaction, every transaction.
Sorry to interrupt,
Yeah.
Adam. But in regards to this previous slide, I have one small doubt. See, what you explained in the previous slide is like Git will be saving only the metadata of the particular file. So
Yes.
how the changes will be getting into the file? Because the reason is only if whatever the changes which I have made in the particular file, it might be a coding, or it might be a Docker file, or it might be in YAML chart or something, YAML file or something. But whatever the changes if I have made in my workstation, if it gets replicated or if it gets check-in in the centralized repository, then only we would be able to use it, or we would be able to share it with for deployment or for testing it. But whereas if it is getting only if it is saving only the snapshots and the metadata, how the changes will be getting into the file?
Okay, so that is where the checkout concept actually does. Okay, so if you want to think, it's the same concept. When you are trying to do a bank transaction, you put a money into your account. Let's say that you go to an ATM, you put or drop some money. How does it get converted into a number? So there is some logic which they internally do, right? In the same way, what we call it as objects. Okay, so that is where you need to understand this concept. When you are trying to do a check-in, what Git does is it will take a collection of certain things. Okay, what is that collection of the thing? So every time a person does a check-in, it takes a snapshot. Okay, so what is a snapshot? Snapshot is like an object which refers to what are the changes that you have done specifically, and along with that, the check-in will also have the details on who modified, when modified. Now, like this, every time you're going to check in, it is going to store a detail. Just like your bank transaction, I was about to say the same thing. Now, in a bank transaction, at any point of time, if you go and take a statement, have you noted, it gives you a transaction ID, and in the transaction ID, it is going to tell what was done. And on the side, it will also tell you at that point of time, what was the amount that was there by which you can calculate everything. So that way, when you say snapshot, every check-in will refer to one snapshot, which will tell you what was modified now and what was there earlier. Okay, now when you do a checkout, it will take this reference and convert it into a file. But now the question again, if you ask little deeper, okay, this check-in is giving me only the changes what I have done, but how will I get all the changes before it? So that is where the meaning of snapshot, when I said what you have now and what you had before. So it knows what it had before. So how does it know? That is again on top of another check-in or another snapshot. So that way, the current snapshot will be using a previous snapshot and it will get the details. So like this, if you go, it becomes something like a linked list. So if you take one check-in or one commit ID, it will refer to what was there earlier and what is now. And if you want to know what you had earlier, you go back. So this way, when you try to do a checkout, what exactly Git will be doing is, with reference to that ID and remaining all of them which has been derived from that, it will get you the details. The same way, like in your bank account, if you go and see your latest, it will be on top of all the previous transactions you did, right? And that's where internally it will be using it. So let's not worry too much into the object, but just think in this way. It stores the information like a linked list, so that when you say that, hey, Git, I want to check out and see this file. So it will first ask you what is the ID in which you want to work. So based on that, it will go internally to a snapshot, and this snapshot will refer to another previous snapshot because it needs to take a difference, and that snapshot will be keep going on. So that is how you will be able to get your entire content of your file or multiple files in your workspace. So that is where every time you do a check-in, what you are going to get is not a simple ID, but that ID has an object which is called as snapshot, and it will also have the details who modified and when was it modified. Okay. And additionally, there is one more information that you're going to store, which is called as a message. Again, compare it with your bank transaction. When you are doing a transaction in a bank, have you noted it will be asking something as a remark? So what is that remark? So remark is like quickly to identify. The same way in Git also, every time when you're going to do a check-in, it will be asking you for a message. And going forward, in Git, we will not be referring as check-in. The other word used for it is commit. So that way, every time you do a check-in or a commit, what you are going to get is a unique 40 characters, which is what we call it as commit ID. And for those who know what is a checksum, so when you say a check-in, what Git will be doing is it will collect all this information and it will convert it into a 64-bit value. And that 64-bit value is what you are going to get it as 40 characters, which is what we call it as checksum. Okay, so that is why it's quite powerful. No one can just modify it at any point of time, because just like a bank transaction, I cannot just go back at some point of time and from the previous transaction, if I add some money, will I get everything? No. Anything that you do will always be referring to the latest, and that will traverse back until the beginning. So that way, what you are going to have in your repository is full of commit IDs, which is nothing but version. And every commit ID will be a collection of data, that is what snapshot, which refers to what you have modified and who modified, when was it modified, and what was the purpose you have modified. Okay, so that's how you're going to have a whole lot of details. Okay.
Sorry, Adam. One more doubt in the previous slide.
Yeah.
So, is it possible? Can I give a request to Git in such a way that I want to merge, or I want a specific commit ID? Like for example, in this checksum, you have shown that this has an initial commit, but after initial commit, I have just for an instance, I have made a couple of changes. So almost like initial plus 3 changes I have made. So and then after that, I have made another 4 to 5 changes, and now it's in the 7th change what I'm right now. So it looks like I have made some mistakes. So I just want to compare it, and I want only the commit ID, which is initial plus 3, and then in mid, can I have such kind of a commit ID reference or a snapshot like that? Is it
Okay.
possible?
So you are not going to actually see any snapshot, because internally when you say check-in, it is going to create a snapshot and that will be converted into a commit ID. But yes, just like your bank transaction, I can have a list of transaction at any point of time. I can go back to a particular transaction and it will show me at that time what was the total amount I had. The same way, every time you modify and check in, you are going to have a list of commit IDs. You can go back to a particular commit. So it is not like I can say that, hey, I will take 2-3 commit IDs. No, at any point of time, you are going to refer to one commit ID, and that will show everything which is there prior to it, just like your bank transaction. Okay, because everything is going to be on top of one another, just like your bank transaction. So start correlating it. So if you want to go back any point of time, you can go back to a commit ID and it will show at that time what and all changes it had, and prior to that, based on that, you can refer to it.
So in that case, we would be able to refer only the metadata of that commit ID, not the exact file or the code we want. It will show only the metadata. Like,
no,
correct?
see, that's what I try to understand. The concept of check-in or commit ID is for Git to show you the details. So you will not be worried about the metadata. Like how I told you, hey, I will go to the bank and I will say, hey, show me exactly what is the detail that I have for this bank transaction. How did it get the bank transaction? That is up to the bank to take care. But at that time, what is the total amount? It will give you. The same way, if you tell to Git, hey, I want to work in this commit ID. So what will Git do? From the metadata, what it knows for that commit ID, it will fetch you the information. So as a user, you're not going to worry about the metadata because that's the responsibility of Git. As a user, what we should just know is what is the commit ID we are having, and from that, what is the file that I'm going to see. So we will refer everything to files, whereas internally it is the responsibility of the Git to take care of the metadata on the snapshot. But it's quite necessary we understand how it is there.
So sorry for this one more clarification, Adam. So whenever if I request for any
Hello.
commit ID, yeah.
Hey, sorry for the interruption. So, like, we are not able to cope up with it. If you don't mind, why don't you push this question every part in the middle? Like, so
Okay.
we are just losing flow actually. So, if you don't mind,
Okay.
will you please?
Yeah, Ganesh, probably just hold on after they finish. I'll clarify your doubts. Okay.
Okay. Okay.
Okay. Now, I've been telling how it is going to store. Now, one more thing is, again, what is it important? See, you might think why this guy is talking about it, because when you really start working in Git, all these things are important. So now if you go back in Git, what did I told you? Everything is a workspace. Now, workspace is nothing but a folder. Now, inside that, you are going to have a repository. So that is where now if you actually see inside your workspace, you are not going to have one area. Now, typically in Git, a workspace can be divided into 3 areas. So what do you mean by 3 areas? So there is one location which is called as repository. And this is where you are going to store everything that you have modified. Okay, so quickly, let me just show you what is that in a diagram. So let's assume this is your workspace. Now, in a workspace, in Git, you are going to divide it into 3 areas. Okay. Now, the 3 areas, what you're seeing here is, one is called as working directory, the other one is called as staging area, then the third one is called as repo. Now, why do you need 3 here? So this is where, first, what you need to understand is, whatever that we understood here, we have a repository, and this is where all your versions or commit IDs will be stored. Just an example, let's say I'm storing commit IDs like this. But what happens now is, when you're trying to get a commit ID, first thing what you will do is, you need to first modify the file. For that, you are going to do a checkout, right? So when you do a checkout, from the repository, it will put it into a working directory. So that is where, in the working directory, you will be able to see the files. Or in other way, working directory is the location inside your workspace where you will be actually seeing the files and modifying the files. Okay. And then once you have modified, you are going to do a check-in. But before the check-in, like I said, you need to generate a snapshot, correct? So that's where the process is. In Git, you are not going to directly check in, but first check out, modify the code in your working directory, and then you are going to take that code and put to another area called staging area. And this is where Git is going to take the snapshot. And then from this staging area, you will be actually doing the check-in. So that is how first you modify and you put the content into staging area where it will try to take the snapshot, and then from there it will collect all the information and create a ID which is called as commit ID. So that is where in every workspace you are working in Git, you are going to have 3 areas, which is quite important. Okay. Now, what you are going to see is only the workspace, because the repository will be a hidden folder inside your workspace, as well as the staging area, whatever I told, is actually not a folder, but it's just a virtual space that is available logically. So that is how internally Git will be creating. So that now tomorrow when we start working, you need to understand that there are 3 areas and accordingly you are going to work. So all the commit gets stored in your repository into a location called as, what is it? Which is the repository. And where you are going to modify the file is what we call it as the working directory. Okay. Now, when you talk about a file, now one thing that if you have to note from other tool, the difference is Git doesn't care about a folder. In other tool, if you try to put an empty folder, it will also try to check in that. But in Git, remember, empty folder doesn't have a value, because a folder has a value only if you put a file inside it. Okay. Now with that, when you are actually trying to create a file, okay, first you will be creating a file in the working directory, and only then you will add it to the staging area and you will put it into the repository. Now, when you try to create a new file, the file will be called as an untracked file. The meaning is there is no information about the file in the repository. That is why it is not tracking. It is called as untracked. But as soon as the file is being put into the repository, then the file is called as tracked file. Tracked means Git knows about it. But when you say a tracked file, see, what do you mean by tracked? You know the information about it. So what is that information? That is where it will clearly tell whether the file that you have, is it modified or not modified. So what do you mean by that? So let's assume you just created a copy of your central repository and you will get it. And when you do a checkout, whatever the commit IDs you have, corresponding to that, you will be seeing some files here. So that way you are seeing the file with what is available in the repo. So there is no difference between what is there in the repo and what you have modified. Then the file is what we call it as unmodified file. Then once you modify the file, there is a difference between the repository content and what you have seen. Then the file is going to be called as modified file. And then when you try to put the file into staging area, Git will call it as staged files. And then when you try to store, what will happen? You are again trying to put it into repository. But as soon as you put into repository, once again, what will happen? The content what you have is same as here. Then the file will become unmodified. So that is how the life cycle of a file is. For the very new file, which is not at all available in the repository, we call it as untracked. But if you are going to work, when you do a checkout, all the files are called as unmodified. And then when you do some changes, it is going to clearly tell you the file as modified. And then when you put into the staging area, the file is called as staged. Then from the staged, you are going to do a commit. So that is where it will be taking the snapshot details and the user details, and it will create a permanent ID called commit ID. Okay. So this is something that you need to know. Okay.
Adam, just one question, just one clarification I wanted at this point.
Can you please hold on for another 3-4 minutes, because I'll just finish the talk. We'll leave it for discussion. Okay, we can have discussion after that. So now, if you understand, I was just talking about how the repository works and what is the internals of the Git. But going back to this particular diagram, if you understand, in Git, there are 2 types of repositories. One is called as local repository, and the other one is called as common repository or central repository. So why do you need two repositories? This is because as a user, you need to have the flexibility to modify and store everything what you need. So that is where you need a repository in which, make this point noted, you need a repository in which you are going to modify and you are going to store and you are going to share the commit IDs. However, when you go to the common repository, we should not allow anyone to modify here. So that is where the central repository or remote repository is meant only for storing and sharing. Okay, so this is how we are going to have two types of repositories. So I'll talk about these probably tomorrow, but in this, try to remember one is local repository and the other one is central repository. So this way, in all your machine, what you are going to have is the local repository. So now, what are the work that you will do? Typically, make a copy of the central repository, which is what we call it as clone. So we will see those commands later. But now understand, in your client machine, what and all you need. So you need to do a copy of the workspace, check out the code, modify the code, check in the code, and then share it to the central repository or to another repository. So this is what you want to do. So that's where the tool that you are going to use to do that is what we call it as Git. Okay, so remember, Git is just a client side tool which will be available in each and every development or each and every user's machine, which will help you to create workspace, check out the code, modify the change, check in the code, and share the code. So that is the only thing that you're going to do. However, if you look at, there is going to be another copy of the workspace which is going to be used by everyone. So that is where the first question that comes is, where should I keep it? So that is where you need to keep it in a common location which can be accessed by everyone. And for that, your Git will not be sufficient. So that is where, if you are going to do the development work and for which if you need a workspace and a tool, then Git will be useful. But if you have a central repository and if you want to manage that, and that is where you need to do a lot of activities, because as a central repository, I told you first, it needs to store everything. So you need to make sure where you are going to store and how you are going to store, who should be accessing it, who should not be accessing it, right? And further, if you want to think of having a backup, where are you going to have a backup? How many people you are going to allow to work? All those things you have to maintain. So that is where in Git, maintaining a central repository is another task that people have to do. So that is where, as a user, you might not be doing it. There might be a central repository available. So you will just install Git in your machine. All you need to know is what is the location of this repository. From that, you will make a copy and you will work. But however, if you want to maintain the central repository, then there are several tools for that. But those tools are called as central repository managers. What is it? Central repository managers. So that is where, if you have a Git repository, which is a central repository, and if you want to maintain, then some of the tools which are available are GitHub, GitLab, Bitbucket, Gerrit, right? So there are plenty of them. So using that, what you are going to do, you are going to maintain your central repository. So that is where in every organization, for doing a continuous development, we need two set of tools and there are two set of people who are going to work. So remember, it doesn't mean that continuous development, I'm going to work on Git. So if you say that, are you working as a normal user where you are going to use the client side of the Git, check out the code, modify everything and store? That is, you're using it for your development, or are you supporting the continuous development for a company or a product? So what do you mean by supporting? So that is where you need to know how to maintain the central repository, where to maintain, how do I do the management of this? How do I give the permission? Who should be working? Who should not be working? How to take a backup? All those things will come. So that is where, depending on the organization, you are going to have another tool which is called as Central Repository Manager. So this is where in DevOps, as an individual, it is not just that, okay, if I use Git, I'll become a DevOps engineer. You are just an engineer who are working on it. But as a DevOps person, if you are thinking of helping an organization, then along with using or implementing a process, you can also take care of the responsibility to maintain a central repository. It could be for one of the project, or it could be only for your team, or it could be for every product that is available in a team. So that is where from team to team it is going to manage. So for this, now you need a tool. Now in that, like I said, there are many tools. Now as we are moving ahead into another way where I don't have to install everything on my machine, that is where there are some tools available which you are going to get it without installing. Okay, now to talk about it, let's just take other example. Now I want to send an email to some person. As an organization, you know that you have Outlook you can install, but without install anything, can't I have a Yahoo or a Gmail? What I have to do, all I have to do is go to a web page, make sure that I have an account, and then using that account I send a mail. Now can I access my Gmail from anywhere? Yes, all I need is one laptop. So that is where you are not doing any installation. Everything is available on the cloud, correct? Everything is available online. So same way, your Facebook, LinkedIn, everything, you don't have to install. Everything is available online. So that way, there are some tools where you can install it in a machine and you can create as a central repository, or there is already available in online. So all you have to do is no installation, create an account and start working. So that way, one such tool which is used for managing your central repository. And what kind of repository? Central Git repository is what we call it as GitHub. And why was this popular? Because it was free earlier. So that is where many open source projects, they wanted to share it online. And if they wanted to do, GitHub was one of the location where no one had to install anything. So this is how now for your practicing or as an organization, if you want to set up something and you don't want to install, you can quickly go to online, that is github.com. Using that, you can directly create a central repository and you can manage. Okay, so that is where most of the people will just say that if you're learning Git, you need to know GitHub. But remember, GitHub is not only the tool, because it's just one of the simple tool for practicing. But as an organization, you go, like many of the people asked, there are a lot of things you have to do in management of the central repository. It's not just about giving user access or permissions. It is not just about taking backup. You should also think about doing a cloning, right? There are a lot of things you have to do. So that is where there are many tools available. Now, couple of the tools which are popular in the market is GitLab. That is one of the tool. But if you're using something like an Atlassian product, then you might have also been using some other tools related to it. Okay, so that is where, remember, GitHub is more of a open source. Now they have also made it as enterprise, but mainly people use GitHub for just storing open source. So for your practicing, it should be good. But as an organization, there are many other central repository tools which you have to think about. One of them popular is GitLab. If not, if you go to AWS, AWS also have their own central repository where you are going to maintain. But understand what is there? Git only. But to manage, you are using a central repository tool. So this is where now when you say you are going to work in continuous development, you need to understand there are two parts of it. Have you used the continuous development process and you have written the code, or have you helped in continuous development for which you have maintained a central repository? So that's where there's a whole bunch of difference between it. Now, being a DevOps engineer, you can do both of them. So that is where it's not just about if someone says that, hey, DevOps means start with Git. Yes, it is a practice, because going forward, you might be modifying a program or a text file or a scripting or a configuration file. But for all of them, you are going to use the client side called Git on your laptop or your machine. But however, there is another set of work which we have to maintain, which is called as central repository. Okay, so this is where we need to understand both of them. Now, as we move forward, we will first understand more of the client side on how you can do on your day-to-day work to modify, store, and check in with all the concept what we have learned. And then we will understand what are the work you are going to do in the central repository. And that is where now, if you are trying to apply for a job, what are the roles and responsibilities that you're going to do? So which is what I was telling in the beginning, that when we explain, we will be explaining everything as a module. So module doesn't mean that you are just going to learn some commands. So understand there's a whole lot of things you need to understand. That is where you will be able to start correlating in your profile in a way that you have used the process, you have followed the best practice, as well as you have also solved the problems in the maintenance, so that you have the ability to drive the projects also. So that's where there's a whole lot of things. It's not just about commands, it's not just about tools. There's a whole lot of things that you need to know, including maintenance, monitoring, right? I'll talk about all of them as we move forward in each tool. So that's a whole logic. Okay, so by this, I'll stop it today. And if there is any questions, please stay back if you want. We will discuss for some time. If not, we have all the groups. Okay, we can just go ahead and take. And by saying it, I'll stop and we'll take the class again at 7:30 tomorrow. Thank you.